cluster troubleshooting. In this nugget, we're going to discuss the actual steps that it's going to take to make sure that your cluster environments remain running as you would want them to. In this nugget, we're going to cover some cluster process verification, just how we can see the health and the commands that we want to run to make sure that health is running as it should be. And then we will move into the actual kernel command injection, where we will talk about the process of using fwctl set and get commands in order to inject different types of command structures into the kernel of the clustering operating system. And we will also talk about using the fwkern.conf file to make sure that any changes that you make to your cluster remain there after a reboot. And then we will discuss the sync network verification, where we will discuss just how we should set up our sync network and how we should make sure that our sync network is going to work in its most efficient manner. So I think you're really going to enjoy some key information here on troubleshooting clusters, and it's going to be some really great on-the-job knowledge and help you lock down the concepts for your CCSC studies. So let's take some great notes and move on to cluster troubleshooting. Okay everyone, let's review some checkpoint cluster troubleshooting steps that you want to know about to help you in your daily work as a network security professional, as well as for your CCSE studies. Now the first thing that you're going to notice here is we have two PuTTY windows opened up to each one of our firewalls. For SSH access, we have Nugget Firewall A1 and Nugget Firewall A2, which participate in our HA mode cluster. So what we're going to do is review some of the CPHA prob commands that you need to use on a daily basis to ensure the health of your checkpoint cluster and just to make sure everything's working as it should be. So let's dive into some of those commands and we'll review that process. Now as we can see, if we do CPHA for prob, hit enter, it's going to give us some actual information. The first thing we're going to see is the CPHA prob stat. You can use either one. If you want to pull that information up, it can be a state command or stat, S-T-A-T, and it's going to give you the same information. But the key is we see the usage right here for these particular commands, and we see the one for -AIF, which is going to give our interface information. We'll take a look at that. But the part I wanted to show you right here is this information that says the following commands are not applicable for third party. What does that mean? That means if you're running a firewall cluster from Resilience, from Crossbeam, from Nokia, or from anybody else who uses the Checkpoint Daemon as the firewall option on the appliances that they sell, this may not work for these particular commands down here. These commands, a lot of them are only going to work in a secure platform based cluster firewall configuration, but that's what that information is basically about, and I just wanted to let you guys know what that meant. So let's go ahead and clear off of this particular option, and we're going to start looking at these commands. The first one we want to take a look at is just a basic command. We pull up the CPHA prob stat command, and it's going to tell us immediately that our cluster mode is a new mode high availability cluster, and it's going to state primary up. It's going to tell us the actual cluster information. We're going to see the unique IP address, and this is our actual sync IPs on each one of our firewalls. It's going to show us our current assigned load is 100% that this current firewall is assuming, and the state of this particular firewall is active, and the one for the backup firewall, the A2 firewall, is standby. So we're in good shape there. Now the next thing we want to look at is, we'll just hit the up arrow here, and you want to get in that habit when you're on the checkpoint command line. I'm sure you're probably already familiar with browsing through the actual CLI interface, but just get in the habit of using your up and down arrows to help you scroll through things. It'll really be a nice time saver for you. So if we do CPHA prob, and then we're going to do -A space IF, and this is going to pull up our actual cluster interface information. As we can see, it's going to say required interfaces are 3. So we have 3 interfaces that participate in our cluster information, and the required secured interface is 1. And what is that for? That is for our sync interface right here. And that's basically stating that that needs to be a secured network between the firewall nodes to pass the state information from firewall 1 to firewall 2 and vice versa. So that information is great. We have that. And the next thing that's really important on this particular entry is the virtual cluster information. What this is stating, these are our cluster virtual IPs, or our VIPs, as they're commonly known, for this particular cluster. We have the 172.20.20.2, which represents our outside of our cluster, and then we have 10.20.1.1, which represents the inside of our virtual IP for our cluster. So definite information, and we want to be able to verify that and make sure that's up on a daily basis. And these type of commands are one of the number one things that I do first time I get to the office, or whenever I first wake up in the morning and I'm networking into my environment, just to make sure that everything's working as it should be. I'll actually go through and do some verification using SmartView Monitor, SmartView Tracker on the GUI side, and then I'll jump into the command line of each firewall and I'll run these type of commands just to make sure everything is working as it should be. It's just a good idea to make sure before the business day gets started that everything in your cluster environment is working as it should be, so you don't get any delays for your employees, which is a good idea and a best security practice, and you probably should be doing that every day if you're managing a firewall environment, which is our end-all go of becoming a CCSE professional, is we want to get that job in network security where we do manage checkpoint firewalls. So that's our second command on our CPHA prob. Now we're going to look at our last command, which is CPHA prob -I space list. And what is that going to give us? That is going to give us our information that makes up our critical cluster processes for our checkpoint clustering mechanism. As we can see, the first thing we're going to see is the interface active check. Are all of the actual cluster interfaces up and in a up status? If they are, that's going to be an OK. And the next thing we're going to see is for the high availability daemon. It's going to say, has it been initialized? Is it working on the cluster? If it is, great, we're in OK status. The next thing we're going to see is for our sync network. Or is everything working in our sync network? OK. And then we also get a last time of report between the synchronization process. Filter, what is this about? Do you have a security policy loaded to the firewalls? If you do, we're in OK status there as well, and we get some information. And the next one is the CPHAD, which is the checkpoint high availability daemon. Is it loaded? Is it working in the operating system of Splat for the clustering mechanism? If it is, we're going to report that as an OK status. And the last one we see is the FWD. So what is this? This is our firewall daemon. Is the actual firewall daemon running where it can inspect traffic and drop traffic as it needs to? Is that running on the cluster? If it is, we're going to report that as an OK status. So each one of these values come together and make up the critical processes that must be running on your cluster in order for everything to work properly and for everything to be in an OK status. Now the next thing I want to show you on a checkpoint cluster in this manner, we need to make sure that one process is running to ensure that the checkpoint HA daemon and everything that's required is going to work properly. And the way that we do that is we're actually going to grep out for our process, and let's do that now. So we're going to do a PS, and we're going to do -EAF space pipe space grep for CP. So that's actually going to print all of our checkpoint processes that are running in the process table. Similar, if you're running just a simple PSAUX, you would list them all, or a top command, you would see those as well for your top processes. But the one that's most critical that we have to look at, and this is this particular file or process right here, which is the CPHA MC set process. This must be running on each one of your cluster nodes in order for things to work properly, and it's something that you should be checking out for verification as you're troubleshooting clusters. That's one thing you want to look for, is make sure that process is up and running for you. So once you can verify all that, you're in pretty good shape. And the next thing you want to look at is your actual var log messages. Your var log messages is going to tell you pretty much everything of what's going on in the operating system level, as well as some of the checkpoint daemon information and kind of a tell-all of things that are happening on this particular machine. So we'll do a more on /var/log, and let's see if we can do messages and see what we get here. Alright. There we go. So we get everything from var log messages, and let's just take a look at what we see here. It's actually going to tell us anytime that the actual firewall daemon starts up or anything on boot up, and we can see the last time we pushed our security policy, it's going to say we are installing our security policy standard on our Nugget Firewall 1, and it actually tells us about ETH3 is not protected by our anti-spoofing feature. And this was an interface I was testing with, so don't let that mess up our network topology or diagramming information. The point is that it's going to tell you what's going on with your firewall. It's going to tell you that it tried to fetch the actual security policy. It says, hey, the local policy is up to date. And it says the policy was not installed because it's the same as the current policy that's on the box. And it's going to enabling bridge forwarding as well as more information as you hit your space bar and you scroll through. It's going to tell you things about starting up your CPU cycle, your IRQs, everything that you need to know. And if you're familiar with Linux in any type of manner, var log messages is going to be a good place to check for errors, problems, or things that are going on in your operating system that could be affecting it. And it's the same thing with using secure platform in our clustering standards, that we want to be able to do verification through this particular file just to make sure things are running as we would like them to. Now that we've covered all the basics of verification and the processes that we want to make sure that are up and running, we're going to get into some of the ways that we can customize our cluster configuration just to get the best performance out of it and to alleviate a few problems that happen every now and then. So let's go ahead and clear off of this screen, and then we'll start with that verification of those type of best practices that I wanted to share with you guys. We reviewed some of the CPHA prob commands, and we looked at some verification and different ways of looking at some of the critical files that need to be running on your firewall cluster to make sure it's running healthy. Now the next thing we want to look at are a few connection table commands that you want to be familiar with. Now the first one here is the actual connections table for the firewall kernel connections that are flowing through your firewall, and that's just an FW tab space -T space connection space -S to give you a summary of that table. And we can see where we're going to see our vals will be our current load, peak is the highest load we have, and the symbolic links are the current links that are back to the actual connection table, which is actually in a hexadecimal format by default. And that's why we see that information. Now the next one you want to look at is actually being able to look at the NAT table. And that's just simply doing an FWX underscore ALOC space -S, and that's going to give you the FWX allocation or xlate values for your network address translation table. And that's how you can do the verification or a summary on what you see in that particular table. So that'll help you definitely for reviewing exactly what's going on and checking the health of your system. So let's go ahead and clear off of this for now. And the next thing that we want to look at is actually jumping into a directory called the actual proc directory. And this proc directory is going to show us a lot of things about the health of our particular operating system, as well as a key value that I want to show you that can really bite you in the foot from time to time if it's not turned on. So we're going to do a CD to /proc. And as we can see, we're on our secondary firewall now. We're just going to do an ls. And once we list everything in here, there's a few values that we want to look at. If we do more for CPU info, we can get information about what type of actual CPU is running on this particular firewall. And as we can see, it's an AMD Phenom 9750 quad-core processor on this particular setup. And we can see this information, and that's really good for doing verification of the actual megahertz and the cache size and everything else that you have running on that particular CPU, for example. And the next one that's really useful is the actual mem info. So if we do mem info, same thing on a more command, we can get information about the actual memory info that's running on this particular firewall as well. And we can actually see our current swap space and all that information, which is very useful for checking out the health of the system. Now the one that I really want to show you, which can definitely bite you from time to time, and that is the actual IP forwarding process that needs to be turned on your firewall. I've seen more people troubleshoot firewalls for hours and hours to figure out this simple process was set to a 0 and should have been set to a 1, and things would have been flowing through the firewall. So let's dive into that particular directory. We're already in proc, so let's go ahead and get into that particular directory. So it's cd to /sys/net/ IPv4, and then under IPv4 we're going to do a more on IP_forward, and this is set to a 1. Now this is the process that's going to allow IP forwarding through the firewall, so it makes it actually functional to be able to pass packets, because by default whenever you do a CP stop or you actually do an FW unload local or anything like that, we want to be able to stop the actual process of packets coming through. More so when you do an FW unload local, of course it's still passing packets, so this value is still set to a 1, but when you actually do a CP stop on your firewall, you want it to actually stop passing packets and turn in basically to a brick at that point. And whenever you're actually troubleshooting things, from time to time, you might need to modify this value from a 1 to a 0 and back and forth, but you can do this inside of this particular file right here. But that's the key file I want you to see inside of this directory that can really bite you from time to time, and you want to be aware of it and just make sure it's turned on whenever you're installing your checkpoint firewalls. The next key value that I want to share with you is a process of a file called fwkern.conf. So what is the fwkern.conf and what is it used for? It's a firewall kernel file that's read on boot up to look for kernel parameters and changes that you want to inject into the firewall kernel. And where does this become valuable? Where from time to time, as you're troubleshooting your checkpoint clusters, and you review some of the checkpoint knowledge base entries, or maybe you work with checkpoint support, they may suggest that you make changes to the firewall kernel to make different processes and things work better in your particular install of your firewall. And that's where we can look at a actual verification process to see how something is running, and then we can see how we're going to set a process inside the kernel, or we're going to inject something into the kernel. Now the fwkern.conf file is going to be there to make sure that whenever we change something and we reboot this particular firewall, those changes make pretty much stay there is what we're looking for. Is that we want to make sure that those changes do not go away if a firewall gets powered off due to a power outage, or just simply rebooting it for maintenance purposes or something. And that's where you need to make sure you're essentially putting this file in so you can save your changes. So what we want to do at this point is we're going to look at an actual verification of a process to see, is it running on our particular system. So we're going to do an fw space ctl space get, and we're going to do fw underscore allow underscore simultaneous and underscore ping. Alright, so it's saying that this get operation didn't work out for us. So we're going to do fwctl get fw underscore allow underscore simultaneous underscore ping. So let's do a verification to make sure that we put that in properly. So it looks like I forgot one parameter here. When we do the fwctl get, we're actually looking for an INT on this actual process whenever we're looking for something from the kernel. And it's going to tell us that our current firewall allow underscore simultaneous ping process is set to a 1. Now what this is, this allows you to ping the actual virtual IP on your cluster as well as the physical interfaces on each cluster member. By default, some checkpoint installations will not allow you to actually ping those particular physical interfaces, say on your standby cluster member, and setting this value allows you to do so, just in case you want to be resilient and checking the verification that that particular member is up, and you want to be able to ping it, you may need to set this value by doing an fwctl set int fw underscore allow underscore simultaneous underscore ping to a 1. So I went ahead and set that earlier, and if we wanted to set that back to its default value of a 0, we would just simply backspace this, do a set, and then off the ping side do a space 0, issue that command, and we would get it back to its default value. So once we have that in place, if we want to do some verification here to see exactly what's going on, we could do an actual fwctl get for this particular value right here, and it would show us what the actual value of this machine was at that point. And that's a good information to learn as you're setting kernel parameters on your checkpoint firewalls. So as we get familiar with a lot of the kernel parameters that we're going to be using, such as setting the simultaneous ping and other ones through the checkpoint fwctl set commands, as we stated, we want to make sure that those survive a reboot, and that's where fwkern is going to help us here. So what we need to do is we need to get into the directory where we're going to build this particular file to make sure that we have our fwkern file in place. So let's go ahead and clear our current session here, and we're going to do an actual cd over to $fwdir /boot, cd over to the modules directory, and inside the modules directory is where we're going to be listing the actual fwkern.conf file. As we can see, we don't see this file by default in this directory. So let's go ahead and put that in place simply by doing a vi to fwkern.conf. Alright, so we're in that file. Now we'll hit escape a couple times. We'll do an I to insert, and we're going to insert this actual value that's stating that whenever we reboot the firewall, we want the fw underscore allow underscore simultaneous underscore ping to be 1. We want it turned on. So any of our kernel parameters that we want to survive a reboot, we need to stick it in the fwkern.conf file in order for it to happen after we reboot the particular firewall. And as it goes to load the firewall daemon information, it will read this file and then inject it into the firewall daemon on boot up, so we'll be in good shape. So as we have this particular value in this file, we need to save it. So we're going to do a colon, write it, quit it, and a bang symbol, and that'll save the file. And we can just do a clear, and we can actually do a more on this particular file just to do some actual verification that we see what we want to see in this file. So we see that the fw underscore simultaneous ping is set to a 1 at this point. So as you start troubleshooting things, as I stated, on your checkpoint clusters, there might be special considerations where you need to stick things in the firewall daemon to survive an actual reboot. And that's what fwkern.conf is going to do for you, and you're going to be finding yourself using this from time to time, and it's just nice to know exactly what it can do for you. And that's the main thing I wanted you to see about the fwkern.conf process. Now we're going to review another process that we really need to pay attention to, and that is our synchronization network. And the process for syncing our traffic between our two firewall nodes becomes very critical and becomes very important that we make sure that it is running as it should be. So what is state synchronization and what is it all about? Well, state synchronization is going to work in two modes. The first mode is going to be a full sync process, where it's going to transfer all the VPN1 kernel table information from one cluster member to another. It is handled by your FWD daemon or your firewall daemon that we saw in the CPHA prob-I space list. We see FWD listed there. That is the actual daemon that is responsible for the sync process to happen between the two firewall nodes, for example. And the next type of process, or the next mode that a sync is going to work in, and that is a delta sync. Now, delta sync is going to transfer changes in kernel tables between the cluster members. So as you make changes or different types of processes or traffic flow through your checkpoint firewall, the Delta Sync process is responsible for transferring that information between the two cluster members. And ever so often you're going to notice that that sync process is going to be running on your network. Now there's a few considerations whenever we're looking at clustering our information between our firewall clusters. We want to make sure that, one, we use the highest available bandwidth that's available between the cluster members. And what I mean by that, let's say if you have a firewall, and on that particular firewall you have a few interfaces. And let's just take a look at our particular interfaces. And we see an IF via ifconfig-a that maybe we have this particular interface right here, ETH1, ETH2, and we see ETH1 is our current sync network, and it's working as our synchronization link between our two firewall nodes. Now let's say if you have a 100 megabit link and you have a few gigabit links, you want to make sure that your synchronization network is the highest available NIC on the machine. Meaning if you have gigabit links on the actual machine and you have fast Ethernet links that are 10/100 links, you want to make sure you're using a gigabit card for your synchronization network, because this has to deal with a ton of traffic between the cluster members, and on an actual cluster that processes many thousands of packets, this could become the bottleneck of your cluster if you don't think about this type of information during the build process. If you already have a cluster in place and you're seeing things like var log messages, and as we'll see with on the pstat process in a few minutes here, that sync is being dropped due to overload, or things are being ignored, or it wasn't synced, or you're just getting poor performance during failover. Saying that basically you're testing your network during an actual outage window or as part of a disaster recovery scenario, you might want to actually physically do a CP stop on your primary node, and you want to make sure that connections that are currently going through your firewall 1 fell over seamless to your users over to firewall 2. Anything that's going to be a TCP type connection, a lot of those type of connections will attempt to rebuild themselves, but things that are short-lived type connections, those type of things, if you have anything UDP based such as for voice calls or anything like that, that type of information needs to be synced properly between the two cluster members in order to just to make sure that you get a seamless failover. Now, the next thing I want you to see here, as we talk about our actual sync process, let's go ahead and clear this particular entry off, and we're going to actually issue an FW space CTL space pstat command. Now, the pstat command is going to give us some actual stats on our particular firewall. We're going to see some information about our machine capacity summary, where we can see our memory use, our concurrent connections, our aggressive aging information, hash kernel memory, system kernel memory, kernel stacks, inspect, all kinds of good stuff about the actual firewall. But what we really want to look at in this particular discussion is synchronization. It's going to show us that our version is new, status able to send and receive sync packets, so we're in good shape. Total sync packets sent is 385, retransmitted 0. That's what you want. You want to make sure that your synchronization network is as efficient as possible. Now keep in mind, on a busy cluster, you're going to see a few packets that are being dropped from time to time. It's not really a huge concern unless that it's consuming more than 25% of your active connections that are going between your firewalls. Say if you have 50,000 connections there and you had 25,000 that were being dropped, you have a problem and you need to look at your sync network. But as we can see here, on our retransmission request, this is set to 0, so we're in good shape there. And the other key value is dropped updates as a result of sync overload, and that is set to 0. And that's what you want on a healthy cluster. Now, the key go here is to make sure that you're not dropping any packets between the cluster members during the synchronization process. And this is where you can use this particular command as well as your cpha-i space list command to make sure synchronization is working as it should be. Now let's just say, for example, we talked about the whole delta sync process from time to time, and we know that the actual sync between our cluster members is handled by a process called the Cluster Control Protocol, which runs over UDP port 8116. So how do you know that it's actually syncing? The easiest way to do that is just do a TCP dump on your actual sync interface. And in this case for us, that's going to be ETH1. And let's issue that. So what do we see here? We see a ton of packets flowing between this cluster member to the other cluster member on UDP port 8116. And as you issue this type of command, it's a constant type of synchronization process where it's constantly taking the state table on this particular firewall and copying it over to the other firewall, just to make sure if we were to fail over something, typically, as we're going to see in this particular series, we should only drop about 1, maybe 2 packets of a ping packet as we look through the actual synchronization process. Now, something else I want you to keep in mind as we dive into our actual dashboard here, actual sync of processes is being held in a couple places. Well, the main thing I want you to see here as we go into, let's say, our internal to internet rule here, we have a process, let's say, for HTTPS. If we open up this particular protocol and we click on advanced, we're going to see an actual option right here to synchronize this connection on a cluster. Now, it's a good idea to make sure that you synchronize only what's very, very, very key traffic to your environment, just to reduce the load on the synchronization network. Now, a lot of people run a crossover cable between the actual cluster nodes in a two node cluster. Now, in some environments that'll work perfectly fine for you, but in a checkpoint secure platform cluster, what that actually does when you take down one of the firewalls or one crashes, it actually is going to send a link down to both firewalls, because this is essentially a crossover cable between them. Best practices are going to state to get a dedicated switch or VLAN that you can put your synchronization interface from each firewall into, and that's pretty much all that's in that switch or in that particular VLAN, and that it's set to gigabit on each link on the firewall, because that'll give you a full duplex connectivity to send basically 2 gigs of data from each firewall in a send and receive type fashion. And we're going to put it in a dedicated switch or a dedicated VLAN to make sure if one firewall goes down, it doesn't make the other firewall register a link down and traffic continues to pass between the two as you would like it to. Now, there's a actual option I want to tell you about, things that are short-lived in your environment, type of connections such as HTTP or DNS, for example. It's a good idea from time to time to go in, if you're starting to see some of that overload error messages and different things like that on your cluster. You can open up HTTP, for example, and go into synchronization on cluster and go ahead and uncheck that. And what that's going to do is it's not going to sync that particular process between your cluster members, because a lot of those type of connections such as that and into your DNS type information, a lot of that type of information is going to be short-lived type connections such as DNS and HTTP. Those kind of things are just going to flow like crazy through your firewall, and that if you're starting to see any kind of performance hit on your sync network, it's a good idea to go ahead and uncheck the synchronization on cluster so it doesn't try to constantly copy general web browsing out to Yahoo or Google or wherever your employees are going, and DNS type traffic that's quite chatty over to the other cluster member. That'll really save the health of your sync network, and it will help you sync what is key Things that are key like Oracle database information, Microsoft share information, exchange processes, email, SMTP, FTP. These are the type of things that you definitely want to be syncing between your cluster members by looking at the actual process that's running. We want to make sure that that's checked off to sync those type of processes. So I just want to make sure that you understand there's a couple options there for your synchronization network that you want to know about, and you want to be able to ensure the health of your sync network, and that's going to be a best practice for sure when we're troubleshooting our checkpoint clusters, just to make sure things are running as they should be. In this nugget on cluster troubleshooting, we learned a ton of valuable information. We went over the actual cluster process verification of using our CPHA prob commands to make sure that we're keeping tabs on all the processes that need to be in place for our clusters to work efficiently, and to make sure that we maintain the standards that we want for a high-level cluster in our environments. Then we looked at the kernel command injection process of using some of the fwctl set commands, and then maintaining those commands using fwkern.conf file. And then we close out the nugget with a discussion on the sync network and the verification, where we talked about a full sync process and a delta sync process, as well as how we should structure our sync networks for their most efficient manner. So I hope this has been informative for you, and I'd like to thank you for viewing.